Hey everyone, so this video is still part of section 6.2, and this video is all just going to be about the laws of exponents. Still in 6.2, there are several you can see here, okay, that we're going to talk about, and just a couple examples at the bottom. But we're going to go through different examples of each rule, each property, and this is important because you want to be able to apply the properties to different expressions, and you also want to be able to identify when a property is being used. So let's get started. Okay, so let's check out this first one here. It's the zero product rule. And so the zero product rule tells us that when we have an exponent of 0, it can simplify to 1. So x to the 0 power is 1. Notice we've got these parentheses here, so x times y raised to the 0 power is 1. 9 raised to the 0 power is 1. Okay, zero product rule. When our power is a 0, it simplifies to 1. The expression simplifies to 1. Okay, here's the next one. A negative exponent rule. A negative exponent rule becomes a fraction. So this is really tricky, so be careful. When we have x raised to the negative a, or a negative number, it becomes positive when we move it to the denominator. So right now, you can see that this is like a fraction, x to the negative a over 1. You're going to move the x to the negative a to the denominator, and the exponent becomes positive. So because we moved it to the denominator, there's nothing left in your numerator, but I still have a numerator, it's a 1. But now the whole term that had the negative exponent is now in the denominator with a positive exponent. So let's check it out again. We've got x to the negative 6 raised x to the negative 6 all over 1. I see a negative exponent. I move it to the denominator, and it becomes positive. And now there's nothing left in my numerator because there was nothing else in this expression. We can do it again. 3 raised to the negative 1 all over 1. I'm going to take that whole expression that has a negative exponent and move it to the denominator, and it becomes a positive exponent. I'm going to show you an example of one where we do have something else. So let's say we have like x to the x times y to the negative 2. All that gets moved to the denominator is the variable with the negative exponent. So y squared moves to the denominator to make it positive, but the x is still in the numerator. There was nothing wrong with the x, so we're going to leave it in the numerator. The other thing I want to show you, which I don't think comes up here, is that if we have something that's negative that's in the denominator, so let's say we have x over y to the negative 2. If I have x divided by y to the negative 2, the negative exponent's in the denominator. If I move it to the numerator, it's going to make it positive. And now it becomes xy squared. There's nothing wrong with the x. It stayed in the numerator the whole time. Okay, so negative exponent rule is you move it to the other side. If it's in the numerator, move it to the denominator. If it's in the denominator, move it to the numerator, and it automatically becomes a positive exponent. So product of powers and quotient of powers, the big thing is that the bases must be the same. So you can see when I say bases, it's referring to that both of these variables are an x. One's an x and one's not a y. They both have to be the same variable. And when we have product of powers, what happens is our exponents add. So we can say this x to the a times x to the b equals x to the a plus b. So I'm going to do x squared times x to the 7th is become x to the 2 plus 7, which we know is x to the 9th. And then I can do 4 squared times 4 to the 5th is 4 to the 2 plus 5, so it gives me 4 to the 7th. So when you're multiplying, this is multiplication, right? Multiplying variables, exponents add. That's right there, exponents add. And then you can kind of think about it for quotient of powers. When you're dividing variables, exponents subtract. So you've got x to the a divided by x to the b equals x to the a minus b, as long as x does not equal 0. So I've got x to the 7th divided by x squared, and so I could do x to the 7 minus 2, which is x to the 5th. Dividing variables, exponents subtract. And here I've got 5 to the 6th divided by 5 squared is going to simplify to 5 to the 6th minus 2, which is 5 to the 4th. So again, make sure all of these, keep an eye, make sure all of these variables or numbers were the same. If this was like 4 squared times 5 to the 3rd, we can't combine these exponents because they're not like terms, right? Think about it in terms of like terms, so we can't do it. Okay, so we've got power of a power or power to a power. We multiply exponents. So we've got x to the a to the b becomes x to the a times b. We multiply our exponents together when we've got a power raised to another power. So y squared to the 8th is y to the 16th. Multiply our exponents. 4 to the 6th to the 3rd power is 4 to the 18th. Multiply your exponents when we have a power to a power. If we have power of a product, so notice these two are different. It's power of a power and power of a product. Product, what comes to mind when you hear the word product is multiplication. And so the difference between these two is, notice we're multiplying these two variables together within the parentheses. When we have multiplication going on inside parentheses, the exponent distributes to every term inside the parentheses. So this becomes x to the a, y to the a. Only when we have a product, only when we're multiplying inside parentheses. So this one is going to become 2 cubed, a cubed, b cubed, which 2 cubed, I know, is 2 times 2 times 2, which is 8, a cubed, b cubed. So you can simplify that more. Let's check out power of a quotient is very similar to power of a product, except now we're dividing. So again, we can distribute. So I can have x to the a over y to the a. I've got a cubed over b cubed, very similar. 3 squared over 5 squared. So then that can simplify to 9 over 25. Okay? So when we're multiplying inside parentheses or dividing inside parentheses is the only time an exponent can be distributed. And then just a little reminder, adding terms with exponents, also called combined like terms, you're only able to add terms when you have the same variable. Only able to add terms when you have the same variable raised to the same power. Okay, so notice in this example, I have the same variable and the same power. I can only combine those two terms I underlined because they have the same variable x and they both are raised to the second power. So that's going to become 1x squared plus 2x squared is going to become 3x squared plus the 4x. I can't combine because notice it doesn't have the same exponent. That one has an exponent of 1. Okay, so let's talk about, we're going to just have a little bit more to talk about here. Numerically contains only numbers and operations. So we can look at expressions just with numbers. That's numerically. Notice we've just got 2 squared times 2 cubed, or algebraically has numbers and variables. X squared times x cubed is going to give me x to the 6th. Just something to think about. In problem 3 here, okay, so rewrite the expressions below using only positive exponents. So when we see 2x to the negative 2 times y, I see I've got a negative exponent. And I look back at my rule. What do I do with negative exponents? Oh, I have to move it to the denominator to make it positive. And that's all we're going to do here. I'm going to write the 2 first because that 2, there's nothing wrong with the 2, right? The x to the negative 2, there's a problem with it. It has a negative exponent, so we're going to move it to the denominator, and it automatically becomes positive. There's nothing wrong with the y, so it's going to stay where it is. Okay, and now I have an expression which I love way better because there's no negative exponents. It has all positive exponents. Let's simplify b. Y to the 0, well, let's think about our rules. I know anything raised to the 0 power is 1, so that's going to automatically simplify. And then notice I have a negative exponent. I have to make it positive, so if I move it to the other side of the fraction, the numerator in this case, it's going to become positive. So I'm going to move it to the numerator. The 1 is there. I don't really need the 1. Because 1 times anything is whatever that number is. And now let's check out C. So we're going to go through it each term at a time. -5, there's nothing wrong with a -5. I'm just going to leave it as a -5. X to the -1, right? If I just look at x to the -1, I have a problem with it, right? Because it's a negative exponent. So I'm going to move it to the denominator to make it positive. Z to the 0 power, anything raised to the 0 power is just 1. So I'm going to put that in there. And then move to the term in the denominator, y cubed. Nothing wrong with a y cubed. To write this a little bit better, -5 times 1 is -5. I got x to the first power. I don't really need to write that 1 times y cubed will be my final answer. Okay. And that is all on our our laws of exponents, that we want to make sure this whole chart is completed and that we understand each of these laws because we're going to have to apply them to simplify expressions. If you have any questions, let me know. Great job, guys.